Hi, so today we're going to learn how to make connections on a breadboard. For the sake of this video, I'm going to make this circuit on a breadboard. I have an annual connection here with me, a battery, resistance R1, resistance R2 and resistance R3. R2 and R3 are connected in series, R1 is connected in parallel. Now in this video I demonstrated both the series and parallel connection and how to put this resistance on a breadboard. Now a breadboard looks like this. I will still show you the demonstration how to make the connection on a real life breadboard, but for the sake of easy explanation I'm going to explain it first on this diagram. I have a 9-volt connection here, 9-volt battery, just I have like this. Now if you look carefully, you can see that if the current flows from here, it has two paths, one to the R1, another one to the R2, and that the current that will flow through R2 will also flow through R3 because these both resistors are connected in series and it is in parallel. I have connected them on a breadboard in the same way. And how have I done this? Let me explain. So this is a jumper wire. It looks like this. Let me focus. It is focused. So it looks like this. We're going to connect them on the breadboard. So a battery has two terminals. One is positive, another is negative. It doesn't matter if you make this one positive or this one positive, it doesn't matter, only the sign will change. Now remember one thing, that in a breadboard current flows in vertical direction, which means that current, if you put a wire here, the current will flow like this and not in the horizontal direction, not like this. So it will flow in the vertical direction, it will go downwards, or if you put the wire here, it will go upward in the vertical direction. Now I have put the wire in this hole. Now the current has actually two paths to go. One is to the R2, another is to R1, as in this diagram. One is to R2, another one is to R1 resistance. Now the current flows in the vertical direction, so some part of the current goes through this resistance and some part goes through this resistance. Now remember that you connect resistance or any element on the breadboard in the horizontal direction. If you don't have enough space, you can still connect them like this, like in vertical direction. You put a wire here, the current will still go through the same, it will still have the same result, but it is recommended that you connect it in the horizontal direction like this, because if you don't have enough space, that's all. So I have connected one terminal of the battery wire that's connected to the positive terminal of the battery here. It has two paths, one goes to the R2, one goes to the R1. Now as the current goes from R2, it goes from here and from here. Now remember, the current flows in the vertical direction, so it will go downwards. I have connected another wire which will take that current to another resistor. Now I could have connected this resistor here and it will eliminate the need of this jumper wire, but to make this I would rather say look cool or not look messy, I have connected it like this, because if you connect both this resistance like this, it will look messy, at least for me. So I have connected it on another side and I have made a jumper wire connection here. So as I was saying, the current will go from here, it will go in the vertical direction, and since it has there is a wire connected to it, all the current will go through here, vertical direction, and it will pass through this resistance. So the same current has passed through R2 and R3 because they were connected in series, R2 and R3. Now as you can see that there is this line, or in the making connections on breadboard we call this a wire. This is not a line, so this is a wire. I have connected the wire because all the current that is going to the circuit has to go back to the battery. Now the current that has gone through and that has passed through this resistance, I have now connected a wire here. Now it will go vertically through this wire, and the current that has gone through this resistance R1 like this goes through this resistance. They all will add up and it will go to the battery. This actually sums up the Kirchhoff current law, that the total current in and out of the circuit is zero. So now I'm going to demonstrate how to make connections on a breadboard. Now I have connected these three resistors on a breadboard just like as it was shown here, R2 and R3 in series and R1 in parallel. R2, R3 in series, R1 in parallel. Now how are we going to connect them in series? Now in order for two elements or two resistors to be connected in series, the same current should flow between them. So I will connect a jumper wire exactly here, and the current that will pass wait, let me grab my pencil. The current that will pass through this resistor will then go towards this wire, and this wire is now connected here. So as this current goes from this wire, it will go in the vertical direction, and since there is a wire in the vertical direction, the current will pass through this wire, and here it will pass through this resistor. So these both resistors are connected in series, and that's how you connect them. I could have, as I was saying earlier, I could have connected it here like this. And the current from here will still go here, and the current between these two resistors will still be the same, but as I said earlier, this looks messy, so I will connect it again like previously. Now these two resistors, this one and this one, are now in series. Now how to make a parallel connection? First of all, what I'm going to do is I'm going to make a room for the both terminals of the battery. So now I'll connect this wire here with like this. So as I said earlier, the current flowing from this wire will have now two paths as it was shown in the diagram, one to this resistance R2 and another to this resistance R1. So now they are both connected in parallel. Now this terminal will be connected to the one terminal, or this end will be connected to one terminal of the battery. Now the current that is going into the circuit must go back to the source. So now I'm now connecting a wire here, and it will go here. So this means that the current that is actually going through this wire will now flow in this I should call it a column. I will connect another wire here, and now this will connect will connect to the one terminal of the battery, or the positive or either negative. Now this is how you connect them in series and parallel.